So let's have a look at how we convert from data into information, and we'll especially look at two very powerful libraries in Panda called NumPy and Pandas. So in the presentation we'll have a look at how arrays are created in matrices, and then how they are used within Python, and then the power of NumPy and Pandas, and also to look at tuples. Okay, so what we want to do is to go from our data. So our data might be numerical values, it might be strings, audio, images, and so on. We then have some hypothesis, and through that we define our analytical tools, such as a correlation function, trends, or even a machine learning model. We then might use some charting tools, such as a table, a pie chart, bar charts, time-based plots, scatter graphs, bubble charts, color maps, histograms, and so on. And for that, we want to really show our information and to articulate something to the user. So this might be in terms of alerting, reporting, auditing, and compliance, some scientific discovery, or even for influencing and for engagement. So in Python, the numeric values in Python are based on a C programming type. So the most simple is a Boolean, true or false. Then we go through 8-bit, 16-bit, 32-bit, and 64-bit integer values. They can be signed or unsigned values, or positive values, or positive and negative. And we can also get either 32-bit or 64-bit floating point values. Python itself doesn't require the casting to a big integer when the values are greater than the range that we've actually defined. It does that automatically. So there are two main methods that we use within Python to represent our data infrastructures, and that's lists and tuples. Lists are represented with the square brackets, and tuples are represented with the rounded brackets. With tuples, what we get is the rounded brackets. And with these, we cannot change the values once we've actually created them. So if we have a data set that we will always keep the same and we don't modify any of the values, then we can use this type. So we can see here that in this data set we've got 4 strings, and we can print out the second string here. But then when we try to modify one of the elements in there, then we get an exception caused. So if we try this one here, we'll see that this is the case. So first what we'll do is we'll try it with the square brackets, and we'll just modify this one. So our list, this is a list, and we'll print out the second element. We start 0, 1, and so on. And in this case, it works because we've modified the second element, and we get that. But if we now modify it, this will now give us an exception because this isn't allowed, because it should be fixed. Okay, so that's the basic difference between our two data types, lists in Python. Okay, so we have arrays, and arrays look like this with numeric values. So we have a number of columns, and we have a number of rows. So we have rows and then columns. So this is a 2D array format, and then each of the elements are numbered 1, 1 to n here. Normally in Python we start with 0, 0, and we would go up to m-1 and n-1 there. but the 0, 0 is the starting point, and it points to this one here. The second one here is referred to as 0, 1, 0, 2, and so on, and this one here is referred to as 1, 0. Okay, so the first value is the row, and the second value is the column. So we can have an array with just one row, or with one column. So this is a 1, 3, and this is a 3, 1. Or we could have a two-dimensional array as a 3 by 3. So this shows some of value here. There's A and B. So if we wanted A times B, then we just multiply each of the elements in there to get these values here. And we do the same again for the next row, and so on. And sometimes what we have is a dot product. In this case, we multiply that one by that one, and then that one by that one, but there, and then add these up together to give this value here. Another operation that we can have is what's called transpose, and that will transpose the rows and the columns so that they're interchanged. So this row here becomes this column here, and that's given the symbol of a T. So let's look at lists in more detail. So as you said, the tuple has the brackets, and we can't change the value. It's what's called a mutable. With a list, we can change the values, and the values themselves can be strings or numeric values. So in this case, we'll create a list with 4 values. We'll print the list out, and then we'll print the second value on the list. And we can see here it comes out as 51. So we'll give this a little try just to make sure that it's giving us what we expect from them. And we'll run this. And we can see where we're printing out the third element here, number 2, and that's 33. We'll print out the first element, and we'll get that. So when we print out the list itself, it will print out the whole list here. And if we just want one of the elements, we can just index it like that. Remember that 0 is the first element. Okay, so that gives us that. We can also create a two-dimensional array. So in this case, we have one row here, and then we have another row there. And then when we're referring to each row, we can refer to as 0 here and as 1 here. We can also refer to a certain element with the row number and then the column number here. So we'll just try this one here. Okay, so we have 10, 51, 33 on our first row, and in our second row here. Okay, so this prints out the first row, this prints out the second row, and this will print out the first row, and then 0, 1, 2, 3. So it should print out 11 here, as it does there. Okay, so we can refer to the whole row, or we can refer to a certain element within inside our list. We can expand that on into what are called dictionaries. So dictionaries are a convenient way where we can actually define a key to a certain column. So in this case, we define IP here as one of the keys. Successful is another one, and unsuccessful is that one. So in this case, we're drawing this table. We have an IP address, and we define the number of successful logins to the IP address and the number of unsuccessful logins from them. So we would structure it in terms of this here for our records. And then we can print out the whole of the dictionary like that, or we can refer to just a single column for for our data. So we'll just give this one a try. Okay, so we're actually seeing the first one in here. So we'll give this one a little try anyway. Okay, so this is referring to our login details then. Okay, so here we are. So we're going to define the first key is IP, next one success and unsuccessful. So we'll print that out, and this is what we get. So we just put a new line in so that we can make it look a bit better. And we'll do the same here. Okay, so in this case, this is our dictionary here. So you can see the IP is our key here, and here is the list that relates to that dictionary value. And if we want, we can print out using the key now. So if we wanted to just print these values out, then we can just do that. Okay, so in this way we can actually refer to our data sets using a unique key. Okay, but the true power of Python is with the ways that we can operate on arrays, and that's using NumPy. In this case, we create an array with NumPy, and then what we'll do is that we'll append 2 rows in this case, print it out, and then we'll transpose the whole of the array that we create. Okay, so we now have very powerful operators that allow for some complex operations. Okay, so here we are. So we're going to create an array here. So we import NumPy here and then define NP, and then we have our array method. This will create a NumPy array. We'll print that out, and then we will add 2 new rows onto that. We can access equals 0 allows us to do that. We'll print that out, and then we'll transpose the whole of that array. So let's give that a try. Okay, so here's the 2 rows that we have for our array, and then there they are there, and we can see here we've added in now 2 new rows into that, and then we've transposed the whole of the matrix with this extra method. So through all of these additional methods that we can actually start to build some really powerful analysis tools. The other thing that we have is to use Pandas. And with Pandas, we typically operate on a data frame. So the data frame itself looks a little bit like a dictionary format, but once it's in there, we can actually start to build quite complex mappings for the data frame. Okay, so if we just give this a little try. Okay, so there's now Pandas here. Pandas is PD. So we'll create our basic data structure with a dictionary there. We'll read that in as a data frame, and then with our data frame we'll just do a very simple capture of one of the keys here. Okay, so we'll see a little bit later on about how powerful this can become. Okay, so in this case, we can see here that we've managed to pull off this column here, and we could just modify this one. We can see that. Okay, so let's look in a bit more detail at NumPy and what it gives us. So in this case, this is just a simple example here. We'll create a NumPy array, or we'll just call it an array here, and we'll just print it. Then what we'll do is that we'll create an array with a sequence from 10 to 30 and steps of 3. And then we use linear spacing, where we can return evenly spaced numbers over a certain interval, in this case 10 evenly spaced numbers between 1 and 10. So these start to show the types of methods that we can use to be able to modify or create our arrays. So just give this one a try. Okay, so the first one is just a very basic array. Second one will create a sequence from 10 to 30, and then the next one will create 10 evenly spaced numbers between 1 and 10. Okay, so we can see there we go. We can easily change that one to 50 and then make that 4, and we'll get our update there. And we might want to have 15 of these numbers. And we can see here that those are 15 evenly spaced numbers between 1 and 10. So it's this power to be able to apply fairly complex operations that gives the power of NumPy. We can also generate random numbers with it. So in this case, we generate a random number between 4 and 10. Okay, so that's generated. We'll generate an array of 4 by 10 of random values. We can see the 2 by 3 one there, 2 rows, 3 columns. And then we can integrate some fairly complex maths. So in this case, we've got solving linear equations. So the answer to this should be 3, and 1 should be able to do that. So 15 plus 3 is 18, that's correct. So let's look at this code. Okay, so we'll just give it a run, and we can see it's solved it there. If we try another one, then we'll get that different result. Okay, so NumPy allows us to be able to integrate some fairly complex mathematical operations once we have it in the format of our arrays. In this case, we can pick off values quite easily with the colon. So if we wanted to reset the values from 1 to 3 to 0, we can do it in a single operation. So if we run that one, we can see 0, 1, 2, and not including 3. So if we wanted to go up to this one, then we can see we can clear out those values here. So it's a fairly powerful method that we have. We can also reshape our arrays. So in this case, we'll take a flat array, one-dimensional array, and we'll make it into a 3 by 4. Okay, so there, hopefully there should be 12 values in there, and we can see that we can create it into 4 as a column. If we wanted, we could go for a 2 by 6, 2 rows, 6 columns, and the reshape method allows us to do that. And then there's a whole lot of mathematical methods that we can integrate into it. sine, sum, average, standard deviation, and so on. So virtually every mathematical method that you can think of is included in here. So in this case, we'll go for sum, average, standard deviation, log, log to the big log, sine, we're going to sort, we're going to get the ceiling and the floor there. So we'll give that a run and see what we get. Okay, so in this case, what we've got sum of that 66, average 5.5, standard deviation, and so on. And we can see the sorting function has been able to sort the values in an array. And there, we can also do the reverse if we need to. And then the ceiling value will round up, and the floor will round down from there. Okay, so these are some fairly complex operations in there. A great thing about NumPy is the way we can operate on the whole of an array with a certain function. So in this case, we'll take an array and we'll multiply it by 2, we'll add 3 onto it, we'll subtract by 4, and we'll divide the whole thing by 2. So you can see here, it's taken all the values and multiplied them by 2. It's added 3 onto these values. It's taken the values and taken 4 away from them. And then here it's divided by 2. If we want to use an integer divide, then we can just do it like that. Okay. So in this way, we can really create complex operations very quickly without long lines of code. And we can do our matrix multiplications and dot products if we require. So we'll try this one here. So we have G and H that I think we saw before. And what we'll do is that we'll multiply the two matrices together, and then we'll create a dot product. So if you remember, we should end up with our 3 by 3 here, and then just our 3 values here. And there we go there. So the dot gives us that 77, 55, 114, where we have a 3 by 3 there. And it's easy really just to change the values in there and for us to be able to process the arrays. So it's an extremely powerful tool that we can use for our operations. Along with this, we can use binary operations, bitwise binary for this. So this is using the binary representation to show our values. So for A and B, we'll use binary representation. We'll show it in 8-bit format. Python has a bin representation, but we can get it more powerful, that we can actually represent it in a binary way with a number of bits. And then we can just flip the bits by using the invert method. And we'll see how that comes out. Then we can use a bitwise AND or exclusive OR, shift left, shift right, and so on. So I'll give this one a try. So we can see there's the bitwise representation there. If we wanted, we could just increase the number of bits if we wanted to represent it slightly differently from there. And you can see the power of this and there. And then we're creating an inverse of our bits. So this is these bits here have been inverted and then shown in an 8-bit format. So we flipped the bits. So we'll take that back to an 8. We should be able to see it easier from there. There we go. So this is the inverse of this is this, and the inverse of this is this. Then we can do an AND operation. 0 and a 1 gives us a 0, and so on. Only when we get 2 1s do we get a 1, and that's represented here. Bitwise OR, XOR, shift by left by 2. So we're taking A and we're moving the bits 2 places. So there's the bits there, and a 0 comes in at that end. When we shift them right, 0s come in at this end, and these bits will move 2 places, and the 2 1s will drop off the end. Okay, so easy just to go ahead and modify our values, and you can see how quick that is. Okay, so now let's look at Pandas, and Pandas allows us to be able to take fairly complex data frames and to modify them, stripping off columns, rebuilding data sets, and so on. So in this case, what we normally do is we read in, say, from a CSV file, and then we can then use Pandas to be able to list the first 3 lines or list the last 3 lines of the data frame. Okay, so we'll just read that in. Okay, and we've created a CSV file here so that the first line identifies the column names that we had before for our dictionary, and then these are the records that are associated with each of the fields. So we'll read that in, and then we'll just list the first 3 values and records in the last 3, and then we'll just print out what the data types actually are. Okay, so we're going to view the first 3 records and the last 3 records. There are 1, 2, 3, 4, 5 records in there, and then we'll print out. Pandas will guess the data type involved. From there, it should see that the first value is a string, and the next values are integers. Okay, so we're printing out the first 3 records here, then we're printing out the last 3, and then it's identifying that this is an object, a string. These next 2 are integers. This one is a float, and the last one is an integer. So if we look back, so this is string, integer, numeric, float, 64-bit float, and string. Okay, so it's automatically casted these values because you can see there's no decimal point in the integer values, and the other ones are strings. Now we'll look at this one. So this shows us the data types from there. Okay, so what we can do is easily pick off one of the columns. So in this case, we have a good login column here. So we'll strip off that column. Okay, so we see we've got good login, so it's taken this column here and displayed it. For the next one, we can use the describe method, and the describe method will automatically take the numeric values and then work out, count the mean value, standard deviation, and so on. So we'll just run that one. So this is the describe method, and we'll be able to do a quick numerical analysis of it. So this is assuming that our data is in a normal distribution, because we're defining it as a standard deviation and a mean. Okay, so there's 5 as a count, there's a mean, standard deviation, minimum value, 25%, 50%, and then a maximum. So it's putting it into 4 quartiles there. Okay, so we can now look at some fairly complex operations. So we can look at just we can sort the values out alphabetically here, and we can also do it in a reverse order. Okay, so we're going to be taking we're going to be sorting the values in location, and then printing the top 3 for the first 3, and then we'll do them in descending order. Okay, so there we go. So Dundee, Glasgow, London, and then we'll do them in reverse here, Oxford, New York, and London. Okay, so in this way we can use the sort values to be able to do a numerical sort, and we can also do that for numeric values. And one of the strengths of this is that we can analyze with a correlation, so we can find the correlations that there are between values, but we can also build data sets together using this format here. So this brings together 2 of the columns into a new data frame, and then we can create the correlation for this one too. Okay, so we'll just run this one. Okay, so this is the correlation function, and this will correlate all the numeric values together. We can also rebuild a new data frame if we build it with the names of the columns. Okay, so the good login is correlated to good login 1, this is perfect, but then bad login is correlated to good login with 0.3 here. And then to the CPU here, that's the correlation between the good logins and the CPU values. And that's using the core method. We can also build the new data frames by taking the 2 columns, and we can just do it with these 2 values here. We can filter our values, so we can find out if a field value is greater than a certain amount, or less than, or equal to. So in this case, we'll build a new data frame by only taking the values which are greater than 12. And we'll print that out. So the values that we've got in there for good login, so good login is 50, 17, 10, 15, 17. So this should only print the values out that are greater than 12. And here they are. Okay, so these values here, we see we've missed out number 2 there because the value is less than 12. In the first one, what we get is the Boolean value to see if it's greater than 12 or not. So you can see that this number 2 value is false. When we rebuild our data set, such as this, then we see we build our data frame out again, and the number 2 record is missing from there. So we can do really complex operations on our data frames. Okay, so that's been an introduction to NumPy and Pandas.